My name is Anirudh Mark. I am a solution architect with AspireNXT, and I've been working with a lot of organizations to transform them digitally. AspireNXT is a 12-year-old organization. We've been a digital transformation organization working with more than 500 customers and over 1,000 projects worldwide. So with that, just moving forward with our competencies and some of our accreditations, we are an AWS advanced consulting partner. As you can see, we have a few competencies under our belt as well as a few partner programs that we've led with. Okay, so with that, I think we can start with a small introduction to our speakers today. Just an introduction. My name, like I said, my name is Anirudh, a technical consultant and solution architect with AspireNXT. We have Mahesh from AWS. He's an enterprise solution architect, and he's very skilled at designing enterprise applications, bringing in cloud strategies for the enterprise market, as well as David Wright. And David is a partner solutions architect from HashiCorp. He is also very skilled in designing your entire IAC roadmap. How do you adopt, adapt, as well as onboard yourself into that journey. Again, I would like to thank everyone for being here. Without further ado, we can get started with some of our content for today. So moving ahead, today's topic is all about cost optimization and how do we bring in infrastructure as code to support that cost optimization principle. So every cloud provider talks about how cost optimization is a key aspect of their well-architected portfolio, right? So any well-architected framework, any framework that supports the cloud strategy talks about cost optimization, right? Now, what's the biggest problem that enterprises face when they onboard to the cloud, right? Or any organization faces when they onboard to the cloud? One is resource underutilization, or over provisioning of resources. Now, what does that mean, right? So when you have an application going on the cloud and you're unaware of what's the size of the application, a lot of organizations tend to size them based on how they would do it on premise, right, without taking into consideration metrics and sizing it based on that. Or and that's when it leads to under provisioning or over provisioning or underutilization of resources on the cloud. And that goes throughout any cloud resource, whether it is a VM or a database or even a service, right? You need to gain insights into the provisioning of your resources. Another problem that leads to cloud-based is ungoverned and ad hoc deployments. What is that, you might ask, right? So that's basically when you have teams that are disjointed from each other. That means you'd have no control over what each team is presenting, right? Or what each team is trying to deploy on the cloud. So when that happens, you have a lot of ad hoc provisioning. So one team wants a web server, and this web server is you go ahead and deploy that web server. Then another team comes in and also needs a web server, unknowing that the web server is already deployed on AWS. This team goes ahead and deploys a web server again, right? And at the end of the day, these web servers are not attended to. They're not tended to. So they become ungoverned. They don't have a power management situation happening, or someone looking to shut down the virtual machine or web server when it's not being used. Now that leads to cloud-based again. And the last one might be resource misconfigurations, right? So someone might misconfigure a resource and then start to reconfigure, and then abandon the resource and start reconfiguring another resource, right? Now resource misconfiguration is also a property of over provisioning, right? Or it could be as simple as leaving unattended volumes hard disks on AWS, right? So once that is done, also you have a lot of costs or cloud waste that come in from these provisioned resources. How do you solve this, right? Now, yeah, how does it happen? So the biggest way this happens is when organizations start adopting the cloud. They move through different phases, right? It could be the POC phase. It could be a a demo phase or whatever, right? So you have a POC account created, and then this POC account becomes ungoverned, and then you have another POC account and another workload, and then the organization moves into putting an application on the cloud, right? Running applications on the cloud. Now, when you're running applications on the cloud is when a lot of organizations establish that center of excellence, right? So when you establish the center of excellence, they understand, okay, yes, these are ways we can go ahead and reduce costs, right? But then it starts, the center of excellence puts in a policy, but unless that policy is enforced, teams start provisioning infrastructure again on their own, right? So you have ungoverned teams going ahead and provisioning infrastructure on their own, moving away from this cloud center of excellence, right? Moving away from these cost optimization policies that have been put into place to govern these applications. Now, when that happens, your cost, keeps going higher and higher and higher, and you keep accumulating more cloud waste on the more cloud waste the more applications you put in, the more POC accounts are created, more dev test environments are gone unattended to, and then it eventually reaches a point to where the finance team comes in and starts questioning, right? Why is our bill so high, right? We forecasted this. This is our budget. Why do we have so much more expenditure compared to our budget, right? Now the biggest question is asked: how do we fix it, right? Now, I believe the answer is infrastructure as code, right? Why is the answer infrastructure as code, right? Infrastructure as code brings in governance, it brings in consistency, and that leads to cost optimization. Why does governance and consistency lead to cost optimization? Because you're able to answer questions like, do we still need these resources, right? How are these resources deployed? Who deployed the resources? Who's the owner? Which cost center is this going to be accredited to, right? So that to be cost attribution also is important, right? Who do we attribute this to, which cost center, so that you know that you're going to move that accountability into that cost center, right? Then you have the option to remove idle resources, and this is something that David's going to show you in a demo towards the end, how idle resources can be addressed by leveraging infrastructure's code, leveraging Terraform's code, right? And also you're able to bring in a certain level of governance so that you can stop over provisioning resources. You can put in limits to teams, right? To dev teams, to DevOps teams, to, to stop the over provisioning of resources, to bring in a right sizing approach from the very beginning, right? So moving forward, HashiCorp's Terraform, right? So I kept talking about infrastructure score, right? So HashiCorp has a brilliant tool called Terraform, right? And that's the star of our webinar today, right? So we're talking about Terraform on AWS, right? Now within Terraform, Terraform is an infrastructure as code platform, right? Now within Terraform, you have a feature called Sentinel, right? What is Sentinel? Sentinel is a policy. Compliance as a policy, right? So you have policy as code written in your Sentinel feature, right? So what does it do today? So for as an example, I'm just going to give you an example on how to stop over provisioning resources, right? So today, as an organization, it's been decided by the Center of Excellence that for all development environments, we are going to stick to 2 cores and 4 GB, right? Now, how do we enforce that throughout the organization, right? And how do we make sure that this infrastructure runs only for maybe 10 hours a day, because that's the normal development time that happens throughout the day, right? And then it's shut down for the day, and then it's spun up again tomorrow, right? So with Sentinel, you're able to bring in these policies, right? Like I said, it's a policy as code engine, right? So you write these policies in your policy as code engine, and then these policies are evaluated, right? So when Terraform deploys an infrastructure, it makes sure that these policies are evaluated and deploys the necessary features to manage your power, to manage the size of the infrastructure, right? So it avoids the mistake of a person deploying a very large instance, therefore increasing prices, right? So this is how we bring in infrastructure as code to go ahead and supplement an additional feature into your governance, into your governance framework, to bring in additional technology to your cloud center of excellence. And we believe technology in the form of infrastructure as code is what would was what is the future of cost optimization, right? Yes, and I have Mahesh over here who's going to talk about the basic principles that AWS is going to bring in, right, from a cost optimization principle, right? And Mahesh has a lot of experience when it comes, because cost optimization and management is one of the biggest pillars from the well-architected framework. And Mahesh is going to take us through a few of those framework basics. So now you can put together Sentinel as your IAC, in HashiCorp's Terraform and Sentinel as your infrastructure as code provider, as well as the core principles that make up cost management and optimization. Put them together, and then you get a beautiful blend of technology and process, technology and framework. And when those meet, you have a very cost optimized infrastructure. And with that, I'm going to hand it over to Mahesh. Mahesh, please take us through the slides.
Thank you, Aniruddha. It's really a pleasure to be here. Thanks, HashiCorp and AspireNXT for arranging this event. And thank you everyone for joining this session today. I'm Mahesh. I'm an enterprise solution architect. I work with the large enterprise team in AWS in India, and I work primarily with the financial services segment. And today I'm going to talk about optimization, specifically cost optimization, and how you can achieve that within AWS. So with that, let's dive into that topic. And first question that I'm going to answer is why cost optimization, right? And now you might be a customer who is already on AWS and you are running production scale workloads, and you are kind of looking at scaling it, right? So you are like an existing customer, or you might be a greenfield customer who is trying to establish or trying to evaluate or experiment on cloud. Now, while cost optimization has the word cost attached to it, but I just want to think about optimization in general, right? What optimization brings is efficiency, right? So you are actually provisioning your infrastructure, be it compute, database, to meet your demands, right? And you are not over provisioning, as Aniruddha said, right? And removing that waste will help you not only optimize your cost, but also optimize your whole architecture. Now, with an optimized architecture, or the architecture which is lean, you have ability to respond to changes, right? So in today's world, you always are in a flux of new demands from the consumers, from the business. You have to have your architecture which is very agile, right? You can't just design something and hope that it will work for the future, right? So optimization and cost optimization is going to help you get that speed, get that flexibility for you to move and change as the things change, right? So that's an important aspect. The second important aspect is, as we all understand, right? So with the growth of data, the growth of consumer demands, we see it's going to be inevitable that the performance demands on your application are going to increase, right? So more and more expectations are increasing, while your resources are going to be limited, right, in terms of what you have. So scaling is very important, right? So at a higher scale, you need to perform, and you need to have your response time, your processing time for analytics workload, or your website performance. If it's a retail website, consumer facing website, it's going to be always under challenge, right? So you have to have this architecture which can scale up and down without you having to have additional resources for really scaling out. Now, when this happens, you have a competitive advantage, right? Your architecture is performant. You are able to deliver value to the business at lower cost, and that's something that's going to be critical. And obviously, the third benefit is you have provisioned, or you have planned for certain budget, right? So you have some kind of budget in mind that you have allocated for AWS cloud and the whole program. And now you look at optimization, and if you are able to save or go below the budget, you have additional savings, right? And we as a AWS, we always want our customers to get maximum value for their investment. So that additional savings can be put back, and you can develop new products and create more innovative experiences for your consumer. So overall, what we see, right, cost optimization is a very, very critical pillar, and it should be something that you should be focusing at any stage of your cloud journey, right? So it forms a critical part of your cloud strategy. Next slide, please. Yeah. Now that we understand that the cloud cost optimization is important, right? So the question is, how do we do that, right? What are the things that I should keep in mind? And I have put it in 4 buckets, right? So what you think of, how do we start from cost optimization? So first thing we need to really realize, right? So in an on-premise environment, right, we had this traditional provisioning of resources and planning. Okay, I need to plan for the future, right? Maybe 3 years, 6 years, or whatever is the tenure in mind. In cloud, we have to think of a consumption model, right? So the fundamental thing is you design your applications, not only applications, but even the persistence layer, the databases, with the consumption model in perspective, right? So it should not be fixed capacity, but you should scale out as demand. And sometimes also be flexible in terms of if your SLAs are okay, you can also buffer resources by having queuing systems. And so always think of a consumption-based model when it comes to designing your architecture, and not just kind of have vertical scaling or highly provisioned, over provisioned resources. So that's going to give you the first advantage, right? And sometimes customers say that, okay, I have constraints because I am buying a vendor product, right? So I can't scale horizontally, right? So we still need to think of how do we have components of your system where you can still have horizontal scaling implemented and give you the benefits. The second important thing here is when you talk about the overall expense, right? One is the platform part, and another is your resources part, right? So what our team is working on provisioning, maintaining that resources. So look at the overall efficiency, right? So what is overall efficiency? In the earlier days, you used to have this whole ticket-based approach, right? Okay, I need a server, I raise a ticket, and then I need a change in firewall, I raise a ticket, and so forth, right? So we had this whole no, a lot of manual activity happening all around, and obviously at cloud scale that is simply not feasible. So look at automation as a lever to address that. And when you automate, you would gain a lot, right? I mean, you will have to invest initially some amount of time in developing those automation, but the benefits are multitude. And you want to make it as self-service as possible, right? So you want to have, of course, the governance rules in place, but make it as independent for your developers and your consumers of your infrastructure to be able to provision resources on demand. I have an example where one of my customers were kind of pivoting their product to a SaaS-based offering, and they had a complex financial services product which used to take about 2 months for them to build the whole product from scratch, right? So they started with there, and they decided, okay, this is not going to happen. I mean, this is not going to work if they want to go into B2B business. So they reinvented, use tools like Terraform, and they are able to provision the entire stack within 17 minutes, right? So that's the power of automation. It really brings in a big change, and this is a customer in India. So you can imagine it is possible to really invest in these tools and gain a lot. And that's the automation piece. And the third piece is what we call it as undifferentiated heavy lifting, right? So you are using a lot of components of your infrastructure. Maybe it's databases, it is message queues, and streaming services, and so forth, right? So AWS promotes or offers managed services, which allows you to kind of give the responsibility to AWS in terms of patching, in terms of taking database backups, and doing the operational housekeeping of the whole services, right? So you would focus on your business problems and bring in innovation and delightful customer experiences, right? So you reduce the IT operation cost from your current team, and then use more managed services. That's another lever you can do. And the fourth area is about managing the expenses, right? So traditionally, you used to have very difficult to allocate expenses to different cost elements. So with things like cost, fine-grained cost allocation, right? So whether it is for the product or it's a different environments, you can allocate expenses to different elements, and then you would be able to have a correlation, right? Let's say I'm doing a campaign management for my customer, and I'm building up an infrastructure to create that campaign management. But what's the expenses that is incurred on that particular infrastructure versus how many new customers I'm getting because of doing the campaign management? So you have a very good correlation that you can make your decision making. So these are the broad level principles of how do you manage cost on AWS. Yeah, so going a little bit deeper, right? So on each of these, so how do I make this happen within AWS? At broad level, we have some things like account structure, which is like an umbrella where you can have a segregation of different parts of your infrastructure, and you can create different accounts for different business units or different environments and have that first level isolation. You have governance control policies, which like one of the example we talked about what kind of infrastructure I can provision. So I can have a service control policy at the very top so that I don't have that. I have the baseline governance and then implement those controls across the accounts, right? So that's the governance piece. Second piece is monitoring, right? Once I have started using the tools, I've started using the infrastructure. How do I monitor it? It's again cost and usage reports. Excellent way for you to have a detailed granular visibility of what is my expense happening, what costs are being consumed, and then the capability to tag. As I said, right, you can really do cost allocation at a very granular level. Have that tagging data ingested into any tool like QuickSight, and you can have dashboards that can really give you detailed visibility. Another aspect is notification. With notifications, you have ability to really get any alerts and anomalies. If there are any sudden spikes in cost, you have ability to in fact control it with something like AWS budgets, right? So again, governance and control are the tools that AWS offers. The third important thing is resource decommissioning, and very, very important thing, and Anil touched upon the volumes example. But quite often I see with customers, they start about, okay, I want to provision a POC account, right? I'm doing some experiment in cloud, I want to do something. Now I build it by hand and I prepare the whole infrastructure. And then the infrastructure team asks, okay, do you still need it? No. So there is a time lag between the POC and the dev. And during that time, I don't know what I have to do with that infrastructure. Do I need to keep it or need to destroy it? If I destroy it, I have to build it all over again. If I keep it for long, I need to bear the cost, right? And that's why I see one of the levers you have is automation, right? Even for POC environments, recommendation is automate infrastructure, right? So that you have ability to, if there is a gap between POC and the development, then you can recreate the infrastructure. You don't have to pay for the cost. So decommissioning, regular decommissioning is a powerful way by which you can control costs for your resources. Next slide, please. Yeah. Then we are talking about cloud, right? Architecture. So you have plenty of services, whether it's databases, whether it's big data processing, whether it is compute. So you have host of options available. So you will obviously decide what suits best based on your access pattern, but also keep the cost angle in mind, right? So evaluate what service is going to be most efficient. So whether you are doing big data processing with EMR or do I need to do with Glue? So there are pros and cons, right? So do analyze the cost angle at every time when you are deciding what type of services you are choosing. And then if you're choosing compute instances, we have variety of instance types. Some are compute optimized, some are memory optimized, and so forth. So we have tool called as compute optimizer, right? So that actually allows you to, that historically scans all your usage patterns and makes recommendation what is going to be giving you the same horsepower, but at lower cost, right? So use those tools to optimize your infrastructure on a regular basis. And then from pricing models, we have some things like on-demand instances, which is pay per use. We have savings plan and reserved instances where you commit for a fixed capacity, and then we have spot instances for fault tolerant workload. So evaluate those different pricing models and make sure that you leverage them to optimize cost. And we'll see some examples of our customers have actually got benefited by using different pricing models. And then finally, data transfer charges, right? So if your application is like you are doing some media content or you're doing a lot of data transfer, make sure that that is factored in. We have, again, ways and means by which you can optimize data transfers within networking environment, like you can minimize the inter-AZ transfer and so forth, right? So make a plan for this miscellaneous data transfer, security services, network services, all those miscellaneous costs also needs to be factored in when you are doing optimization. Yeah, so one of the challenge which customers say, AWS has a lot of services, right? And obviously we have evolved as customer demands for newer and newer capability, and we continue to innovate, right? So obviously one of the recommendation here is for you to continuously look at what I have deployed and what is coming from AWS. Is there some opportunity for me to review that workload, review that architecture? And one of my customer, again, an example, they had this GP2 instance, GP2 storage type, right, for SSD storage, and they saw that okay, GP3 has come, and they evaluated that, and they got a huge amount of improvement in their performance because of this improving the instance storage type. So keep this focus in mind, okay, and maybe you need to have dedicated cost optimization functions which looks at this newer capabilities that are coming across the stack and keep evaluating over a period of time. Next, please. Yeah, so just to summarize, what are the different tools and services that we offer? So we dipped into the planning phase where we talked about AWS organizations to establish the high-level governance. I mentioned AWS budgets, which allows you to really have a tight control and anomaly detection and things like that. And then we talked about ability to have visibility, right? So Cost Explorer gives you visibility, fine-grained information along with tags. You can really drill down what is really my spend going to be. And then finally, we talked about savings with the commercial options in terms of savings plan where you commit for resources. We have things like spot instances for fault-tolerant workloads. So these are different tools and services that are available. We didn't dive into each one of them, but definitely you have host of options available to optimize cost from AWS side. Some of the customer success stories, Arista, an Indonesian company who had a challenge, right? So their costs were in fact doubling, and it was a huge challenge. They engaged one of our partners to investigate what can be done, and again using AWS cost optimization practices, they were able to reduce cost by 20%. So a situation where they were actually doubling, now they are actually reducing the costs on a monthly basis, and they were able to use those savings into expanding their business further. Yeah, next, please. Another customer story from India, were actually doing a lot of big data processing, and as a part of that processing, their costs were spiraling up, right? Again, they looked at this problem and evaluated spot instances, reducing the cost by 60%, right, for their big data processing. Not only that, they were able to lower the time, right? The time required for them to make changes was like around 6 days, and it now is half a day, right? So huge improvement in terms of ability to respond to the time to market and saving the cost at the same time. So double benefit is what they got. So likewise, moving ahead, we have next slide, please. Yeah, we have host of customer success stories, and these are some of them. And if you look at it, these are using spot instances, but you see the benefit that customers are going to have saved the cost, but also have a huge impact on their business outcomes, right? In terms of reducing the time to market, or trying to reduce the whole cycle time or the customer response time. So just look at cost optimization, not just for the money saved, but also from the other business outcomes that it can lead to. And something that you can invest your time. And I mean, as I said, automation is the key for you to look at. So with that, I have completed my portion. I would like to initiate a short poll to kind of keep you engaged. I see there are some questions, but maybe we will first go through the poll. So Aniruddha, you want to walk through the poll process?
Thanks, Mahesh. So just two short questions, right? So guys, all attendees, if you guys could just view the poll that's on your screen. The first question is, very straightforward. What from our conversation today is the benefits of infrastructure as code, right? So please go ahead and answer. The second question, which point below is not a part of the well-architected best practices frame, for cost optimization? So I'm just going to give it a few minutes or a second to, go ahead and for everyone to finish the poll. In the meantime, I see that there is a question from Shashidhar. Mahesh, I'm going to let you take this. It is on how to recover from spot losses. So.
Yeah, Shashidhar. So obviously Spot is requiring you to have the workload which is fault tolerant. Obviously that is a prerequisite. So things like big data workloads, media processing, those are the ideal cases where you have basically a workload should have an ability to at a 2 minutes notice interval. Those workloads will be you have an option to either terminate or hibernate those instances. So you will have to kind of have those capabilities in your workloads. If your workloads are suitable for that, definitely you can look at using Spot.
Thanks, Mahesh. Yeah. So with that, I'm just going to go ahead and read out the poll answers. For the first one, what is the benefit of infrastructure as code? Faster speed and consistency. efficient software development lifecycle, reduce management overhead, or all of the above? Yes, the answer is all of the above, because infrastructure as code does bring in a certain level of operational benefits to reduce your management overhead. Because of that, you therefore reduce your software development lifecycle process, makes it more efficient, which then brings in agility into your process, right? The second question, what below is not a part of the well-architected best practices for cost optimization? Enabling traceability, cost-effective resources, match supply and demand, optimizing over time. The answer is enabling traceability. Though it is a part of the well-architected framework, it is not part of the well-architected best practice for cost optimization. It is for your security practice, right? So that's basically a quick poll. With that, I think we're going to move into a small demo. So I'm going to pass it on to David. David, like I said, is our partner solutions architect from HashiCorp, and he's going to take you through a demo through some of the concepts that we've talked about today. So over to you, David.
Thank you. And I think there's a couple of key things that I just wanted to kind of cover off that were key to this kind of demo making sense. So the first of those is obviously this is Terraform Cloud. Terraform Cloud is part of a workflow mechanism that allows you to control those workload specific criteria and deploying. By implementing infrastructure as code, which is fundamentally what Terraform Cloud is going to be driving, you are looking at how you can then put a repeatable set of patterns into play. And so in this construct, we have our workspace in our organization. Our organization is our ability to carve up the Terraform Cloud, your Terraform Cloud into different business groups. So you can see I have different organizations that I could work out of here. And this workspace then creates a unique working environment to control a particular construct. So if we take a look at that construct, you can see here that this is tied to a particular repo that, again, having version control and a single point or single source of truth linked into your overall strategy around how you're going to provision your workflow. You have the single source of truth, which is easier said than done, to drive your Terraform infrastructure. Now, you can link this so that when you link to this repository, any adds, moves, changes, or commits into this repo are then a trigger for building out that environment. Again, having that control and using the codified approach to actually driving infrastructure. Again, some of the things we talked about, having repeatability, having control over the environment, using automation to drive changes with the minimum amount of effect or the maximum amount of effect, and also having the ability to tear that up and pull it down as you see fit. And so here you can see the actual code, very reasonable, simple set of code. You have our provider, so our mechanisms to talk into AWS APIs. You have an image we're going to stand up that's defined as a particular criteria. So that could be for sizing, as as was mentioned earlier. It could be for particular environment types. And then we actually deploy it. And so if we look at how our variables are defined, so we have our variables, these are the things that we actually want to, and instant types that we're going to define, and they will run within our, let me just move that bar out of the way, they will run within our environment. So in our environment, if we take a look at it, that is the fundamentals for setting up and running our policy. If we started to do a plan, you can see that a plan is fetched. We start to think about what we are going to build. So this is actually taking that code set, is running it as a plan to see what will be actually created. And then in this case, we have our instance and we have an output that is going to create. So this is what I'm going to, let me expand that. This is what I'm going to build. And you can see in here, we have some things that we know. We have a lot of things that we don't know because that won't happen until after the build. So this is still at the plan stage. And that means there's a gap between, and this is some outputs that we are defining. And so we can see here that we've actually run a cost estimate. And so in this, we have some defined hourly cost, rolling it up to a monthly cost and creating an overall delta. And if we wanted to, we could then confirm and apply that, which obviously, or you could have this auto-approved. So this could then run through and stand up. Now, it's good to know that there is a cost and some sort of cost estimation with that, but then how do you apply that policy and Sentinel policies around that? And so you do that by then defining those that control. So we go into our settings. We go into our policy sets. We create a new policy set. We link our VCS. So all of these things are using repositories. They're using a single source of truth to drive that policy set. We connect our policy set. We now go into our policy set here, and we are going to select a particular workspace, update policy set. Here we're going to select our policy that we want to run it against, add the workspace in, update our policy set. So now if we go back to our workspace, we'll run a new plan. And in this time, what we're seeing is now you can see we've added in this policy check. And so as this runs through, you'll see that it will run through, hopefully, depending on the infrastructure. There we go. We've got our plan being queued again, deciding on what it is going to do. Got our infrastructure there. Plan is still running through, done a cost, and there we have a policy fail. Oh, what have I done? I think I've actually tagged the wrong policy to it. But you can see that as the workflow goes through, in between the plan and the apply, we have tagged in the policy to actually look at that. So if we go into our repo, we can look at what the policy is that we would want to, there you go. That's the one that we should have applied. Now this is actually then enforcing a monthly cost control. So let's go back to our policy and enforce the right policy into our workflow. Let's go into settings, policy sets. We need to change. That's the one we want. And you can see how easy this is to just actually, once you have those policies defined in the back end, you can see it's really very easy to actually go into your VCS, see where the policies are you need to update, save and change those updates. All of that beauty of using the as code approach. And Sentinel uses that same as code approach to kind of build out your policy sets and define what those elements that you need to deploy are. So let's go into here, take a new action, run a plan again. And now when this runs through, we should see that what we actually get is then a quantification with that Sentinel policy, as this AspireNXT team showed earlier, where the policy is actually enforcing a degree of control based on that cost optimization. And so what this is doing is tying in the ability to actually not only define whether the infrastructure meets the requirements. So here we see, yes, it comes in at less than the requirement, but you actually have a forcible control to do that before the infrastructure is stood up. So if this infrastructure had failed that, for example, you could have we're using a soft mandatory mechanism here, which means that the Sentinel policy has the ability to be overridden even. If we enforce the hard mandatory, then we could actually enforce a check that would mean that policy, if that policy wasn't met, it would not be able to continue. And therefore, now you're starting to be able to build and take some of those pillars from, say, AWS best practices around cost control and even well architected, and enforce those around your infrastructure before you stand it up. And so combining, leveraging that as code approach, using a VCS, using the workflow within Terraform Cloud, and applying these things so that you have an overall structure that allows you to really tie an as code and a preemptive approach to deploying your infrastructure. Because what you have to remember is, until I confirm and apply this has not actually been built. This Ubuntu image is nothing but something as a call, and we haven't actually deployed it into our infrastructure yet. And so this means that by taking this kind of approach, you can set and build policies that meet well architected frameworks. You can enforce tagging so that things such as do I know this is in demo? Do I know that who owns this? Do I know when or if this should even be running? You could enforce things such as tagging that would say that this is this is a dev instance, and so as a part of that dev instance, you could then run a Lambda function that later went through up and had a clear up function of anything that was tagged demo. So now you're starting to tie preemptive control, i.e. this has to conform to a set standard that I need the infrastructure to do before it is actually applied and stood up. And you can take that well-architected framework, apply those best practices to those policies. There are Sentinel policies available that also are pre-canned that you can use to help enforce some of those criteria. Build it into your workflow, and now you have a mechanism to actually apply this into your infrastructure before it is stood up. Another thing that I just wanted to touch on is you can also leverage modularization as well. So not only is cost control about being able to enforce what modules or being able to enforce what happens to your infrastructure before you stand it up, but it's also, taking that infrastructure as code approach to what is best practices, what is repeatability, and how do I take advantage of that. And so within Terraform Cloud, you also have the ability to use a private module registry. And so what that is you have the ability to take a public registry module, such as creating an S3 bucket. You can customize that in your own private repo to create a very specific module that could be enforcing a particular replication. It could be enforcing data encryption. It could be meeting particular content upload sizes and building some policies around that. And then because this is part of the workspace, because it is also definable, you can then make that a private module registry, which can only or has to be consumed from within the environment. So if we take a look at our private module code here, for example, you can see that it's actually referenceable as the source pulled from Terraform Cloud. And again, what this means is now you have set in concept of like a landing zone or a repeatable pattern that again that you can then build those best practices into. So that could be a whole VPC. It could be something as just something as simple as a particular type of environment app, and again apply preemptive control around that so that someone deploying it could only deploy that module. That module has a dev test and production version. You could enforce that based on the tagging and where it's being deployed. And again, you're putting overall control onto that environment. And so with that, that's kind of all I wanted to share. So I'll hand you back to the AspireNXT team to ask the last, to take us home with the last bit of the webinar.
Thank you, David. So in the meantime, before I end this slide, we do have 2 questions in our Q&A section. So if you guys have any more questions, please go ahead and drop it in Q&A or in chat, and we'll be able to answer them. The first question is, does scalability have anything to do with cloud cost optimization? I would say yes, right? And I'd like Mahesh, if you want to, chime in on this. Definitely has, an effect on cloud optimization, right? The reason I say this is because you don't need to run all your applications at a specific capacity at all times, right? By leveraging the cloud's on-demand resources, you're able to scale your application whenever you require it, right? So what does that mean from a cost perspective? From a cost perspective, you're not building applications like you would on-prem, right? You're not building applications thinking about 5 years in the future, what it's going to scale, right? Thinking about what's my peak going to be, right? Because when you do it on-prem, you're going to think, okay, I need this much traffic to handle this much resource to handle my peak. So I build my infrastructure according to that, right? But when you're on the cloud, you don't think about that. You think about, hey, can my application scale? When I do hit my peak, do I need to, what is the sizing I'm going to require, right? And that's how you set your scaling policies, because that inadvertently goes ahead and talks to your for cost perspective, right? Because from a cost perspective, you're only going to pay for what you use. That means when you scale, for those few hours or days that you scaled up for, you pay for that. But when it scales back down, you're going back to a low price point, right? So I would say yes. Mahesh, if you have anything to add to that.
Yeah, sure. So obviously, the cloud is designed to be elastic, right? So we have designed cloud so that you would take advantage of elasticity. And as what Aniruddha was saying, absolutely, examples where we can see cyclic workloads, right? So we have customers who have peaks and lows. Like for example, they are running maybe capital market kind of a scenario, right? Think about they have certain peak hours, and then they have some hours where there are less number of users, and then there are some batch jobs that run at the end of the night, right? So you have this cyclicity in the workload access pattern. And normally what happens, customers design for some kind of an estimate, right? So I will go to size for the peak. If I size for the peak, I'm going to have a lot of waste. And if I size for lower sizes, then obviously I'm not able to meet the demands, right? So that's where we see the elasticity of cloud coming into picture. And it could be also, I've seen a lot of customers who are doing things like seasonal workload, right? So if you have Diwali or some kind of an event where you are doing some campaign and you're getting a lot of customers. So again, that is an area where people can take advantage of cloud.
Thanks, Mahesh. Another question is, what benefits do we have as an organization if we opt for cloud? From a cost perspective, you're moving from CapEx to OpEx. From a scalability perspective, you're definitely increasing the ability to scale as an organization. You're bringing in agility for your organization. Now agility always brings in, the speed to market, your ability to innovate, right? From application modernization to adopting technologies. These are, few of the benefits that you can bring in when you go ahead and opt for cloud. Another interesting question we have today is on top of the AWS cost optimization and cost budget services that we have, right? How do we leverage Terraform as a cost solution, right? Now, Terraform is an infrastructure as code solution, and David, please do correct me if I miss out on anything. Now, being an infrastructure as code solution, you're able to leverage, like we saw today through David's demo, Sentinel, right? Sentinel as a policy, as a code engine, helps you control costs by bringing in governance. right? So that's how you leverage infrastructure as code, right? It brings in this governance framework that brings in a, like, now that you have a framework, you're able to use this framework to define cost optimization rules, to define cost strategies, right? From tagging resources, it could be as simple as tagging resources, or from power management, so that you're able to build repeatable infrastructure, right? That lets you make sure that infrastructure is not running 24/7. An example would be what happened during the COVID pandemic, right? A very well-known organization, huge, right? The place is known as the happiest place on earth. Basically runs all their infrastructure on cloud providers like AWS, right? So their AWS cloud infrastructure was created using Terraform. Now, during the pandemic, obviously they had to shut down all their theme parks, a lot of their stores were closed, right? So there was no need for them to run this infrastructure anymore, right? So what they did was they went and destroyed all this infrastructure, because there was no need for that application to run, and there was no requirement for them to pay extra, for this, infrastructure. So what they did was they went ahead and destroyed that infrastructure, and they kept the data, obviously. And when they did reopen eventually, they were able to just run their infrastructure, Terraform code, and spin up infrastructure, right? So for those months that they were not running AWS infrastructure, they didn't have to pay for that infrastructure, right? And when they needed it, it was available on demand. So that's how you can use Terraform from a cost perspective. David, if you want to add anything.
Yeah, I think there's also the, you mentioned Sentinel and the policies, and I think there's a fundamental mechanism around automation too, which is just key. All of the things that we've talked about, all of the things that are benefits of the cloud, all of the elements around using an API approach to delivering your infrastructure is all fundamentally driven around automation. And automation allows you to then be flexible, faster, innovative, all of those things that are key to why the cloud, why people are using it, why it's being adopted. And so Terraform is becoming a de facto standard in terms of many developers around the infrastructure as code tool of choice, because it gives them a flexibility, because there is a whole bunch of community supported and based elements that they can use and leverage in terms of building and getting started faster. But fundamentally, automation is going to be key to getting your infrastructure clearly defined, easy to manage, having sets of repeatability, which then set you up for then how do I do control, governance, compliance over the top of that, using then a framework like Sentinel and leveraging, again, predefined best practices from AWS or CIS or one of those types of environments that clearly can work into your as code approach and look at delivering automation into your infrastructure.
Thank you, David. I'm just going to give it a minute to see if anyone has any more questions, or if you do feel like you have more questions, you can always reach out to us also. Now, just to move into how can we engage post this webinar, right? Post this webinar, our call to action, right? So what can we do? You can obviously connect with us if you want to do a well-architected review around your cloud infrastructure. If you can, you want to have a one-on-one session to discuss cloud strategies, or take a deeper dive into the different cost optimization principles available, right? And this could be a joint discovery session with HashiCorp as well as AWS, and AspireNXT as a partner with AWS and HashiCorp, right? And define those strategies and bring in various cost perspectives from an ISC code level too. We also have a special bundle offer from HashiCorp on their infrastructure automation platform, right? By leveraging, how do you leverage Terraform Cloud Business? So there are 3 bundles available at 3 different price points depending on how you're using the cloud today. And we can, through that connect with us, we can help you decide, which bundle works best for you. And also there is, please do register your interest in the upcoming hands-on workshop with Terraform, where you get to work on, the code, you get to deploy your own infrastructure with Terraform, and you understand it in a deeper dive, right? And you'd be getting that link through the email or the feedback email that you get at the end of this webinar session. So I'm just going to do a quick check for any more questions, and if not, I would love to thank everyone for coming here today on behalf of AspireNXT and the speakers and the principals here, HashiCorp and AWS. Definitely love to thank you guys for being a part of this webinar today, and listening to us talk about the various strategies and cost savings on the cloud, leveraging both AWS as well as Terraform. Right. I think that's it. Have a good day, guys, and thank you again for joining.
Thank you, everybody.